Okay, for question 16, now we have inequalities or we need to graph them. We're going to also follow kind of the same rules by making y equals or y by itself. So in this case, we want to get y by itself, so we need to subtract the 2 to both sides. This cancels. So this is y is greater than or equal to negative 7/2 x minus 2. Now the reason I did not flip the symbol or switch it around is because I did not divide or multiply by a negative. All I did was subtract. Okay, I did not multiply or divide, so the symbol stayed the same. So then we go, this is we're gonna graph this. This means that it's gonna be a solid line, that equal sign. And we're going to graph it the same way we graphed on question 15, where we find the slope and the y-intercept. My y-intercept is negative 2, so we go to negative 2. It's a solid point because it's a solid line. My slope is negative 7, so I'm going to be going down 7 over to the right 2. So my line should look something like this because it's going down. So just FYI. So starting at the y-intercept, we're going to go at negative 2, we're going to go down 7 over 2. Here's my y-intercept. Down 7. Okay. 1, 2, 3, 4, 5, 6, 7 over 2. And if I want to go the opposite direction, I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7 over 2. And here's my line. You can use a ruler or your formula chart to make it nice and straight. Something like that. Okay, so here it says that y is greater than. Now, greater than would be above the line. Here's my line, and the thing above is on this side. So I would be shading this part. And that would be my answer. All of these points make the inequality true. All of them. And you can test them. And I like to use a point to test because I want to make sure that I'm shading the correct one. And let's go ahead. Let me just go ahead and finish shading here. Doesn't have to be perfect, but all of these are answers. All of these would be answers to the inequality. Any point in this shaded area would make the inequality true. Now let's check. Let's choose a test point. So I'm going to choose this point. It's not on the line. You can only choose test points that are not on the line. So I'm going to choose 0, 0. I could choose 4, 4, 2, 2, any point on here. I just want to choose 0, 0 because it's a lot quicker. And we're going to plug it in, 0, 0. So here for y, I'm going to put 0 is greater than or equal to negative 7/2 multiply by 0 because that's what my x is, minus 2. Now negative 7/2 times 0 is 0, and 0 minus 2 is negative 2. So now I have 0 is greater than or equal to negative 2. Is 0 greater than negative 2? Is that true or false? That is true. 0 is bigger than negative 2. So like I said, all of these points make this part true. All of it. All those points satisfy the inequality. Let's go ahead and do another one. Oops. Taking a while. Sorry. Alright, we have to graph it. We have to graph it once again, make it y equals, or in this case y inequality symbol. So we need to move over the 2x, negative 2x, so when we move it over to the other side, we have to get the opposite sign. That would be plus 2x, plus 2x. So I have 3y is greater than 2x plus 12. I like to put the x first, because that's like will give you your slope. Then we need to divide by 3. And here I have y is, the symbol does not flip. Why? Because I divided by a positive, not by a negative. 2/3 x, 12 divided by 3 is positive 4. And we are going to graph that. So my y-intercept is 4, and this is a dashed line, not a solid line. So that means that the points on the line do not make it true, do not satisfy the inequality. So we go to positive 4 for my y-intercept. Here's my positive 4. I'm going to do an open circle because it's not included as part of my answer. It's an open, it's dashed. Positive 4, 2/3, rise over run, up 2, run 3. It's positive, so it's going to go up 2. 1, 2, 1, 2, 3. Open inequality, a circle. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And you continue the pattern. I'm going to continue this way. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And it is a dashed line. Does not, because the numbers on the line do not satisfy the inequality. So then here I have y is greater than, and here's my line. Greater than would be above the line, so we would shade this top part. But let's just make sure that we're shading the right spot. Let's choose a test point. Once again, let's choose 0, 0. So you can either substitute 0, 0 here, or you can substitute it here. It doesn't matter. It should work for both. Let's go ahead and plug it in for here. So then I have here now, let me work it out over here. 0, because I'm substituting it there, is greater than 2/3 times 0 plus 4. 2/3 times 0 is 0. So then I have 0 is greater than 4. Is that true or false? That is false. 0 is not greater than. So if this is false, then that means this section must be true. Which is what I said earlier, because here it's saying y is greater than, and all of these above the line are greater than. So all of these would make it true. If you don't believe me, you can choose a point in the shaded region, and it would make the inequality true. If you notice, I like to choose 0, 0, but if 0, 0 is on the line, you cannot choose 0, 0. Choose a different point. You can choose 1, 1, or 2, 2, or 7, 7, any point you would want. Okay. Let's go ahead and do one more, because it's inequalities. 16. Graph the solution set of that. Once again, we want y by itself. So I'm going to move this 7y to the other side so that I can have y by itself, and then we can move the x to the other side. So let me go ahead and move the y. Do I flip the symbol? No, because you're just subtracting. So here I have negative 3x. Positive 2 and negative 7 is negative 5y is greater than 10. Because this moved to the other side. And then we want the 3x to the other side. So negative 3x to the other side. We get the opposite sign. Positive 3x. Positive 3x. This cancels. So I have negative 5y is greater than 3x plus 10. We are going to divide by negative 5 because we want y by itself. So I'm going to divide by negative 5, divide by negative 5, divide by negative 5. Here this cancels out because we want positive y by itself. Y, this is negative 3/5 x. 10 divided by negative 5 is negative 2. Now, I divided by a negative. Now, because I did divide by a negative, that's important. The symbol flips whenever you multiply or divide by a negative. So now it's, instead of being greater than, it is less than. It's important that you remember that rule. Now let's go ahead and graph it. Well, it is a dashed line. Doesn't have the equal underneath it. So let's go to the y-intercept. The y-intercept is -2. So open circle at -2. My slope is negative, so that means I'm going to be going down 3 over 5. Here's -2, down 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Down 3, 1, 2, 3, 1, 2, 3, 4, 5. Same thing over here. Opposite. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And it is dashed. There we go. This says y is less than, so it would be above or below? It would be below because it's less than. Let's go ahead and choose a test point. I can choose my beloved 0, 0. So let's plug in 0, 0 here. So I have 0 is less than 0. Oh, that doesn't look good. Let me go ahead and work it out somewhere else. Hold on. Okay, so I'm going to have 0 is less than -3/5 times 0 minus 2. And this becomes 0, 0 minus 2. So then I have 0 is less than -2. Is 0 less than -2? No, it's not. It's greater than. This ends up being false. So this is false. So we shade the other side. The other side should be true, which is what I said. Y is less than. Less than would be below the line. And there we go. All of these are your answers, your solutions. Of course, not anything on the line, because the line wouldn't make it true, because it's dashed, it's open. Anything that's below the line is true.